continuing this section, we looked at these profiles. Let's now define acidity and alkalinity. Once again, I think you're intuitively aware of what they mean, right? Something that is acidic, for example, if you drink Coca-Cola, you feel a slight burning sensation that is related to acidity, or when you drink it, hydrogen plus ions are being released from the CO2 carbonic acid that's in the Coca-Cola, and that's going to burn a little. So acid releases H plus ion when it's dissolved in water. That's what makes it acidic. Alkaline or base basically releases hydroxide ions, or OH minus, in water. How do we measure it? We have something called the pH scale, which you have learned in school before, I'm sure. It measures the hydrogen concentration, and it's not a linear scale, it's a log scale, because the quantity varies by a lot. By using log scale, you can represent it better. So pH of less than 7 is called acidic, and pH value greater than 7, we call it alkaline, and neutral is what pH 7 is, which is the dividing line. And the pure water, even though it's polar, because the molecules are constantly attaching to each other in hydrogen bonds, water is basically neutral, so you end up with a pH of 7, which is neutral. Here is the pH scale. The battery acid, it's called acid because it's very acidic, and its pH is down below 1. There are lots of acids in our stomach needed for digestion, which is around 1, and then you have lemon juice and tomato, grapes, juices, or fruits and vegetables, beer and coffee, rainwater, milk, and so on are all acidic because their pH is less than 7. Okay, remember again that this is a log scale, not a linear scale. So a lot of people circulate WhatsApp messages saying mango, banana, and so on have pH of 9, 10, and so on. You should immediately check whether this is true or not. Your curiosity must make you check whether these pHs that are being circulated as cures for corona and so on are actually true. They are not. So be careful, okay? So what are the alkaline things? Eggs, or blood, seawater, which is what our main interest is here, things like bleach and ammonia and oven cleaner and the things we use for neutralizing stomach acid like milk of magnesia and so on and so forth. So seawater, as we have already mentioned a little bit before, maintains its pH or alkalinity around 8.1, and it has remained so for many million years. It becomes important again when we look at global warming, because as we increase CO2 in the atmosphere, and CO2 is highly soluble in water, it's going to go into the ocean, and it's going to shift the pH towards being more acidic. What's the problem? Turns out acidification of the ocean can create a lot of trouble for many of the species that live in the water, like the corals. Okay, we'll see why that happens. What is the profile of ocean pH like? Here we are near the surface looking at a pH of about 8.1 on average. Can vary a lot based on whether you are near the coast, near the coastal river discharge, and so on and so forth. And just like CO2 increases with depth to about 1 kilometer, you expect the acidity to increase along with acidity to increase along with CO2, which means the pH will decrease. Remember, lower pH means higher acidity. So pH drops to about 7.6 or less, where the CO2 is maximum, and then it becomes almost flat or slightly increases. Again, we will see why this profile is the way it is at deeper depths. It has to do with ocean circulation and where the deeper waters actually come from. As we mentioned, ocean has a wind-driven circulation where winds are dragging around the ocean, and there is density-driven circulation where heavier waters are formed by processes like ice formation or evaporation, which increase the density, and the water sinks. When water sinks from near the surface, it's going to bring down some of the properties with it, so that affects the deep oceans because the deep ocean water is coming from near the surface. Depends on how far that water is from where the water is sinking as well. We will see that later on. So that's this module on residence times, oxygen and CO2 profiles, which are critical, and this pH scale, which is very critical, that we will come back to.